scientific theory is in opposition to the God theory?
Well, I would say it's the one that tries to explain the fine-tuning of our universe. Those 10 laws, those 10 laws and constants of nature that I alluded to earlier, explain those in terms of statistics, in terms of saying, well, this implies that there's got to be lots and lots of other universes that are different from ours. In fact, if you read Leonard Susskind's book, he talks about string theory. Now, this predicts that there should be 10 to the 500th power other universes. Now, that's 1 followed by 500 zeros, a number that's beyond imagination, practically. So many other universes that are all different from each other, in order to have ours be just one of that ensemble. So ours is not special, it's just one of the statistically different ones, and we're in this one because we couldn't live in any other one. That explains it. Well, that's in opposition to the God theory. It's perfectly legitimate. If you want to believe that, you can. I'm not going to argue that I can disprove that. I can't. I just don't happen to prefer that one. I happen to prefer the one that says there is an intelligence behind the universe, and the reason the universe has these fine-tunings is because the objective of the universe is to be able to let life forms originate and evolve so that this consciousness that is eternal can enter into those life forms and experience what it's like to live in a physical universe. Because that experience is much richer than simply the potential of being able to do it, not doing it. It's like, as you mentioned earlier, like having a game that you design but never play.
As an astrophysicist, how far away do you think is the nearest universe or nearest planet like ours, or unlike ours, but the nearest planet that could sustain life?
Well, it could be a few dozen light years. We've discovered about 350 planets so far, orbiting around other stars. Now, most of those are not at all the kind of planets that you'd want to have for life, because they're mainly very heavy planets, and that's just an accident of the way they're discovered. The technique used to discover them just makes it impossible to detect Earth-like planets yet. Now, there's a mission that NASA just launched called the Kepler mission, whose job it is to find planets like the Earth by surveying something like 100,000 stars and looking for the transit, that is, the passage of planets across the line of sight between us and the star, causing a dimming of the starlight.
Right.
Within 5 years or so, that should detect hundreds of planets, many of them like the Earth. So the odds of there being an Earth-like planet anywhere nearby is pretty high. So somewhere in the local neighborhood of stars, which might be, 10, 50 light years away, there almost certainly is going to be another Earth-like planet of some sort.
And that's interesting in particular, if we're looking at the distance that we enjoy from the sun, that if we were as close as Mercury, there couldn't be any life that would sustain on this planet, or if we were further away, like Neptune, that there wouldn't be sustainable life, and so that there's some sort of almost magic distance between a planet and a sun in order for there to be the perfect ingredients for life? That's
right. There is what you call a habitable zone, which is where a planet would receive just the right amount of radiation from a star so that the temperature is right for water and carbon chemistry to be able to function and life to originate. So you need just the right kind of conditions, both in terms of the actual physical situation of the planet and how it's located with respect to the star.
And that habitable zone would change in distance depending on the temperature of that sun. That's right.
Yeah, the different kinds of stars have different amounts of radiation, and so you'd want a star pretty much like our sun, or a little bit smaller, not some star that's enormously bright, because the really bright stars tend not to live very long. They have very, very short lifetimes. You want a stable environment for billions of years for life to evolve.
What's a short lifetime in astrophysics?
100 million years.
100 million years.
Yeah, that's pretty short astronomically.
And that's too short astronomically in order for life to grow and evolve.
That's right. I mean, life has had a little over 4 billion years on the Earth, so I guess that's about the right length of time.
Although that could go back to that theory about how if the sun were breaking down and that Earth-like planet that was orbiting knew it, that necessity being the mother of invention, they might have the same amount of intelligence as we have. They just have a greater inspiration to try to get away from that sun before it goes out.
I suppose so.
Well, it's just me reading too many comic books, I guess. And so the astrophysicists are going to be able to. They know where the suns are. They just haven't been able to measure yet how many Earth shadows, as it were, are passing in front of that sun to be able to see who might be, how far away the next universe is that would have a habitable zone.
Well, don't confuse distance from the Earth with the universe. We're talking about the stars that we're looking at with the Kepler mission are all in our universe. Our universe is huge. And the galaxy we live in, the Milky Way galaxy, that alone has 400 billion stars in it. So there's lots of opportunity even within our own galaxy.
Of course.
Yeah.
Sorry, that I definitely shows you again. Sometimes I struggle with being able to keep all of these definitions in my mind, and it's so interesting yet at the same time. So if that's as far away as we would have to go, that perhaps would it be possible that within our children's lifetime or our grandchildren's lifetime that we might be able to get a ship of some sort to one of those planets if we had the right propulsion system, if we were able to harness, say, dark energy, we might be able to make it to one of those planets?
Well, there are two obstacles. One is that the kind of propulsion we have today is just impossible to work because propulsion requires that you carry a propellant along, that you throw out the back of the rocket. Well, the further you go, the more propellant you have to carry. And pretty soon you're carrying propellant, just propel the propellant. It gets to be literally astronomically impossible.
Right, but but coming up with a different propulsion system, could we do it?
And then that takes us to the second problem. Even with a better propulsion system, physics as we know it limits us to the speed of light. So yes, you could do it, but it would be a long trip. Now, it may not be such a long trip if you're on board because of time dilation, as relativity shows that time passes at different rates for different velocities. However, as far as the civilization is concerned, they would be launching a mission into space that might last a century or more. Well, that's unlikely. It's a very costly thing to do when you get no rewards back from it anytime soon. So there are the obstacles of the limit of the speed of light in addition to the propellant problem. So it's a difficult thing. I think that the only way we'll get there, maybe I'm being too pessimistic, but the only way to get there would be something new that we haven't really done yet, something like a wormhole or slipping into some other dimension and zipping through that space that has different physical laws and popping back out where we want to. That's the sort of wild ideas that come out of string theory because there you talk about other dimensions that may have very different properties than ours. So it could be something totally radical like that gives us the ability to go there.
And wormholes themselves are still theoretical, correct?
Correct, yeah. No one's ever discovered a wormhole.
Okay, so we don't even know where the nearest wormhole might be.
No.
Right, okay. Would it be weird if it were like in Cleveland?
You're right.
Just hadn't found it yet, but it was there waiting for us all along. Well, what a great way to end the hour here with Dr. Bernard Haisch as we go into our last hour, your chance to get involved in the conversation. We could go with 0 point fields. We could go with the discussion we're having about the God theory. Any number of different ways along the way that you relate to this topic. Coming up, we'll take your calls next for Dr. Bernard Haisch. You can link up to him and the work that he's doing on the digital universe as well through coasttocoastam.com and find out more, too, about the work that he's doing through the website. And then, of course, too, coming up, we'll get to our last little bit here online. If there was a story I forgot to mention earlier, I want to get into the very end of the show. It also ties into this next on Coast to Coast AM. This is Ian Punnett.